Ah, number 6. Lovely number 6. A couple ways to interpret number 6 here. One would be dividing the input by 2. So that's going to be a dilation. By the way, y equals the absolute value. That's the overarching theme. That's the parent function. Reflect, dilate, translate. I would say no. I don't see a negative out here. I don't see a negative on this x. No reflections. So it's going to be an upright. It might be a little bit wider, and it might be shifted or translated, but there's no reflection. It's right side up. There is going to be a dilation, and there will be some translations to take care of. Let's take a look at the dilation. Let's just graph real quick the parent function over here. Go ahead and knock that out. Next, we take a look at the dilation. You can think of it two ways. Horizontal dilation by a factor of 2. Or vertical dilation by a factor of 1/2. You see, with the absolute value function, there's really no difference to writing this function this way or bringing that 1/2 dividing by 2 out like this. Really no difference. You have to kind of watch out with the square root and the parabola with doing that. But with the absolute value, if you have it dividing by 2, dividing by 3, you can just pull that out and make it times 1/2 or times 1/3. If you were dividing by 10, you could call it times 1/10 on the outside. So you could either think of this v as flattening downward by a scale factor of 1/2 or stretching horizontally by a factor of 2. Doesn't matter to me. I'm going to go ahead and think of it this way. All of the y's are going to get cut in half. 1, 1 will be 1 comma 1/2. 2, 2 will be 2 comma 1. 4, 4 will be 4 comma 2. And the v widens. Another way to think of it is this line is going up 1 over 2, up 1 over 2. Because of that slope, 1/2. Get it? Got it? Good. Go the other way. Negative. In the negative direction, it's going up 1, left 2, up 1, left 2. It stretches out like that. Next, we need to take this and bump it. I think we're going to go right 4. And we're going to go up 1. So take the whole v and bump it right 2, 3, 4, and up 1. From there, let's just recreate the v. Up 1 over 2, up 1 over 2, up 1 over 2. On the other side, so blue will be my final answer. Up 1, left 2, up 1, left 2, up 1, left 2. There we go. Final answer for this graph would look like this. Let's talk about checking the v. See, when we check with a table of values, whether you're doing an absolute value function or a parabola, you want to start your table of values by thinking about where the vertex will be. Wherever that vertex will be the number for x that you use in the middle of the table. The middle of the table here will begin when x is 4. Why the heck would I use 4? You want to look inside the parent function, inside the absolute value bars. Ignore everything else. Just look inside those bars. What would you put in for x there to produce 0? Of course, 4. So 4 is where you make your vertex in the middle of the table of values. Choose two numbers larger than 4 and choose two numbers smaller than 4. You could use 5 and 6, and you could use 3 and 2. You could certainly say 5, 6, 3, 2. Okay, 2 up here. But I'm going to actually skip. I'm going to use 4, 6, 8, and 4, 2, 0. The reason is I'm dividing by 2. I'm multiplying by 1/2. I don't want any decimals. I don't like decimals. So I'm going to use even numbers. Check it out. Put in 4. 4 minus 4, 0. 0 over 2, 0. Absolute value of 0, 0. 0 plus 1, 1. Is 4 comma 1 on our graph? You betcha. Let's put in 6. Why did I skip 5? I'll show you right now. 6 minus 4, 2. Half of 2, 1. If we would have used 5, we would have had 1.5. So we would have had 0.5, sorry. Or 1.5 is our final answer. Put in 6. 6 minus 4 is 2. Half of 2 is 1. 1 plus 1 is 2. Put in 8. You can use either of these. 8 minus 4 is 4. Divided by 2 is 2. 2 plus 1 is 3. Look, 6 comma 2, 8 comma 3, looking pretty good. On the other side, we have, now, if you just test those, you're going to see that. All right, you're just going to see the right side of your V. That doesn't make sense. Also plug in 2 and 0 just to check. 2 minus 4, negative 2. Negative 2 divided by 2, negative 1. Absolute value of negative 1, 1. 1 plus 1, 2. 0 produces 3. I see symmetry there. I see my y's, 1, 2, 3, 1, 2, 3. That produces the symmetry of the absolute value V. That concludes the going over of the homework 4.4 to 4.6. Hope you enjoyed it. Any questions, let me know. Use the discussion tab or ask me in class tomorrow.